Microwave tubes, reflex klystrons, first part, series on microwave engineering, lecture number 4.21. Reflex klystrons are microwave tubes. They are low power, low efficiency microwave oscillators. They employ an electron gun and a single re-entrant cavity along with a repeller plate. The electrons emitted by the electron gun are accelerated to high values of velocity with the help of accelerating anode. These electrons, which are formed into a beam, are then passed through the grid gap of the cavity. While passing through the gap, they get velocity modulated. As a result, different electrons enter into the repeller region with different velocities. They travel different amounts of distances into the repeller region. They spend different amounts of time in the repeller region and then return back to the cavity gap. By the time they reach the cavity gap, they come together, not all, some, forming into a bunch. This bunch then crosses the gap, giving energy to the gap. Broadly, this is the functioning mechanism of reflex klystron oscillators. In the present session, the focus is mainly on structural features of reflex klystron, description of its functioning, beam coupling quotient, transit time of the electrons, bunching parameter, in addition to some more important aspects of the device. Now, let us move to the core session. We begin with certain general introductory statements pertaining to reflex klystrons. Reflex klystrons are low power, low efficiency microwave oscillators. Their power output is relatively small. Their efficiency is small. It is less than 20%. We are going to see. Their output falls in the microwave band. That's why they are microwave oscillators. They are oscillators. They are primarily used as signal sources in microwave generators, as local oscillators in microwave receivers, as pump oscillators in parametric amplifiers, and also as frequency modulated oscillators in portable microwave links. They have good number of applications in microwave engineering. Some are mentioned here. Their power output ranges from 10 milliwatts to 3 watts. It is small. Frequency ranges from 4 to 200 gigahertz. This range covers almost the entire traditional microwave band. The basic parts of this tube are beam emitter, electron gun, an electron accelerator, one re-entrant cavity, and a repeller plate. These are basic parts that go into the design of reflex klystron oscillators. The structural features of the oscillator, they are illustrated here. Here is an electron gun. Electron gun consists of a heater coil and a cathode plate. It emits electrons. These electrons are then accelerated by an anode plate which is connected to a positive voltage V0. V0 is accelerating voltage. After acceleration, these electrons achieve high velocities. They form into a beam and then they cross the gap, cavity gap. Across the cavity gap, there is possibility to access several frequency components, but dimensions of the cavity, they are selected in such a way that one component, only one component can exist and grow. Other components die down soon once the functioning of the device starts. That particular component is here indicated as Vs equal to V1 sine omega t. V1 is its amplitude. The electron beam while crossing gets velocity modulated by the voltage across the cavity gap. Different electrons then enter into the repeller region with different velocities. They travel different amounts of distances into the repeller region. They spend different amounts of time in the repeller region and then they return back. The repeller voltage, the distance of repeller plate L, these are all selected in such a way that most of the electrons, by the time they return back to the cavity gap, they form into a bunch. Bunch is a thin, highly dense cloud of electrons. Then this cloud crosses the gap, delivering energy to the cavity gap. Notice the dimensions, the voltages, they are selected in such a way that the bunch crosses the gap on the face of maximum opposition for its movement, on the face of maximum amount of repulsion for their movement, for their crossing of the cavity gap. The delivered signal, high amplitude signal, is then extracted, taken out using a current loop. Here it is indicated as RF output. D is here shown as the grid gap, L as the distance of repeller plate, VR is the voltage over the repeller plate. So all the parts that are shown here are parts of klystron oscillator. Some points, critical points regarding the functioning of device. The electron beam emitted is accelerated to high velocities by the accelerating voltage V0, and while passing through the grid gap, the beam gets velocity modulated. Velocity modulated beam then enters into the repeller region where it faces a repulsive field established by the repeller electrode. All the electrons which cross the grid gap during a half cycle from positive peak to negative peak come together, forming a bunch after spending different amounts of time in the repeller region. Notice here bunching limits are positive peak to negative peak. Bunching range is from positive peak to negative peak. In case of klystron amplifiers, bunching range is from negative peak to positive peak. The bunch, which is thin dense electron cloud, then crosses the gap, giving energy to the gap. For maximum energy transfer, the existing gap voltage must be large and must be opposing. This is an important aspect, opposing the bunch movement. The functioning of reflex klystrons can be further understood by considering Applegate diagram. In this diagram, one can see the gap voltage. This is gap voltage, single component. Electrons crossing the gap during the variation of gap voltage from positive peak to negative peak. These electrons, they participate in the bunching process. Electrons which cross from negative peak to positive peak, they don't participate in bunching process. Therefore, the energy that is given the electrons which cross the gap from negative peak to positive peak, this energy goes waste, or half of the input energy is wasted in the operation of reflex klystrons. So their efficiency is less than 50%. Now, the electrons which form into bunches, they are arranged in such a way that crossing is maximum and opposed. Therefore, beam has to cross at the instant when gap voltage is positive and maximum. It has to cross for energy transfer to the gap. It has to cross either here or positive peak of next cycle. So the transit time of the electron in the repeller region it has to be either 3 by 40 or 1 3 by 40 or 2 3 by 40 or 4 3 by 4t. Here t is time period of the signal. We are going to see 3 by 4t is not possible for a different reason. First possible mode is then 1 3 by 4 mode. Now, one or two points regarding bunch formation. Consider the electron that is crossing the gap when the gap voltage is positive and maximum. Electron A. This electron gets accelerated, it gets some more velocity, therefore it travels deeper. It is able to travel deeper into the repeller region and then returns back to the cavity. Consider the electron that crosses at the instant B where the gap voltage is 0. Then it gets neither acceleration nor deceleration. Its velocity remains as it is. When it entered into the cavity with that velocity, it enters into the repeller region and returns back. Notice here the distance it entered, the B electron entered, is less than the distance electron A entered. Also, the time electron B spent in the repeller region is less than the time spent by electron A. We consider another electron C. The electron C electron or the electron which is crossing at the instant C, it faces opposition, it gets deceleration, its velocity decreases. Therefore, this electron then enters a small distance into the repeller region and then returns back. Now, consider one more aspect also as far as these three electrons are concerned. Electron which crossed at instant A, it is the earliest electron which entered into the repeller region. Then B entered. Lastly, C. C is the latest, whereas A is the earliest. A spends more time, B moderate time, C small amount of. So considering entries, considering durations they spend in the repeller region, now we can understand the possibility of these three electrons reaching simultaneously the grid gap. Simultaneously present at the grid gap means they are in the form of a bunch, thin, highly dense electron bunch. Not only these three electrons, all electrons that cross between A and B or B and C, all these electrons, possibility is there for them to reach the gap at one instant and participating in the bunch process. Other electrons, we can see they cannot be part of the bunch. In the analysis of reflex klystrons, usually we follow certain reference. Oscillator is assumed lying along z-axis with its grid walls at z equal to 0 and z equal to d. Electrons are accelerated to high velocities by voltage V0. So V0 is always indicates, it refers to accelerating voltage. Reference electron enters the cavity gap at the instant T0 and leaves it at T1. What is a reference electron? Reference electron is one which crosses the gap when gap voltage is 0. And the instant at which it enters into the cavity gap, it is indicated T0. Its exit is indicated by T1. The same electron returns back to the gap at T2. The timeline diagram of electrons in reflex klystron is shown here. This is electron beam. It is accelerated to high velocities using voltage source V0. The velocities they acquire, it is indicated by small V0. They enter cavity gap at instant T0. They leave the gap at T1. These are standard symbols. And the electron then, reference electron then enters into the repeller region. Here it faces opposing force. Why? Repeller is connected to a negative voltage source. Then it turns back, travels towards gap, reaches the gap. Let us suppose the instant at which it reaches is T2. Z equal to 0 is the location of one grid wall. Z equal to D is location of another grid wall. This is a repeller plate. Some points regarding velocity modulation. The velocity with which the electrons leave the buncher gap is given by a formula. This formula is known as equation of velocity modulation. It describes the velocities of electrons when they enter into repeller region. First, let us see what is this equation. V stands for velocity. T1 is just now, T1 is introduced as the instant at which electrons leave the grid gap, and V naught is velocity to which the electrons are accelerated by the accelerating voltage. Beta I is beam coupling quotient. V1 is amplitude of the grid gap voltage. V naught is accelerating voltage. Omega is angular frequency. T1 already explained. Theta G is grid gap transit angle. Here is an grid gap, an electron passes through it. It takes some time to cross the gap. Let us say it is tau. Now multiply this tau with omega. It gives you theta G, grid gap transit angle. The quantity in the equation beta I V1 by V0. This quantity is called depth of velocity modulation. Derivation of this equation is not that much difficult. What we have to do is equate these two quantities. E V0 is equal to half m V0 square. It gives an expression for V0, and then the electron undergoes certain amount of acceleration or deceleration due to the grid gap voltage. Once that particular aspect is taken into account, it results in this equation. A few points regarding beam coupling quotient. It measures the interaction between electron beam and the cavity gap. It can be defined as the ratio of alternating current over the cavity to the AC component of beam current. It is given by this formula. Beta is, symbol for beam coupling quotient is beta. Beta is sine theta G by 2 by theta G by 2. What is theta G? I have already explained. Here angle theta G is average gap transit angle for the electrons. Theta G is equal to omega tau, where tau is average gap transit time for electrons. Tau is nearly equal to T1 minus T0, the width of the gap divided by velocity of the electron beam. Now, what is the idea? What is the concept behind beam coupling quotient? Here is cavity. It is re-entrant cavity. Electron beam is made to run through the cavity gap. This is cavity. When the beam is crossing the gap, there exists an interaction between the cavity and beam. There exists mutual influence between them. How much is the interaction? How much is this mutual influence? It is measured by a quantity. That quantity is called beam coupling quotient. Maximum value it can assume is 1. Some points regarding transit time. Here, transit time refers to repeller region transit time. There are two transit times in reflex klystrons. One transit time refers to transit of grid gap by the electron. Another transit time refers to transit of repeller region by the electron. Here, the second one we are going to discuss about. The force equation of electron in the repeller region is given by this formula. This is repeller plate. It is connected to a negative voltage VR, and there exists field here, and electrons keep on entering into this region. Here, they face opposition to their movement into the repeller region. They get decelerated. The amount of force they experience is given by Coulomb's law. E is charge of the electron, E is field intensity. Capital E is field intensity in the repeller range. According to Newton's law, when a particle experiences force, then it moves with the acceleration. That acceleration depends upon the amount of the force. Acceleration and force, they are related through m d square z by dt square. It gives acceleration. This factor. M is mass of the electron. It is equal to minus E. Field intensity in the repeller region can be found as Vr plus V naught by L. L is length of the repeller region. Now this equation can be solved to find Z. Here Z indicates position of the electron in the repeller region at an instant t equal to t. From this equation, the transit time in the repeller region, it can be determined. T2 minus T1. It is usually indicated by T prime. It can be found equal to 2 ml. M is mass of the electron, L is length of the repeller region. V stands for velocity of the electron at instant T1. E is charge on the electron. V are repeller voltage, V naught is accelerating voltage. So T prime is transit time in the repeller region. It is given by this formula. As already mentioned, transit time is the time duration the electrons take to come back to the cavity gap after being forced into the repeller region. It is given by this formula. T prime equal to T naught prime 1 plus beta I V1 by 2 V naught sine omega T1 minus theta G by 2. Of course, it is T2 minus T1. This relation one can obtain without any difficulty by substituting expression for velocity in the expression for T prime given in the previous slide. Now, what is T naught prime? It is the transit time of DC electron in the repeller region. It is equal to 2m LV naught by E VR plus V naught. If we multiply T prime with omega, it gives an angle. That angle is denoted by theta prime here. It is actually round trip transit angle of electrons. It can be found equal to theta naught prime plus x prime sine omega T1 minus theta G by 2. In this expression, there is theta naught prime. What is it? This is round trip DC transit angle of center of bunch electron. It is equal to omega T naught prime equal to 2m omega L V naught by E VR plus V naught. The meaning of all these symbols, they are given several times by now, so I don't think they are again required to be explained. Here x prime is bunching parameter. It is given by symbol is x prime equal to beta I V1 to V naught theta naught prime. Bunching parameter has some special significance and it actually indicates the degree of bunching as well as waveform of the density modulated beam. These are some of the things which I want to share with you for right now about reflex klystron. To recap, structural features, idea behind the functioning and some critical parameters pertaining to the functioning of the device are all introduced, described, elaborated in the present session. Enough for now. Hope you have a wonderful and beautiful and enriching and enchanting learning experience. See you again soon in another session. Bye.